Nuclear fusion power is a form of energy generation that could generate electricity from the energy released during nuclear fusion reactions. Nuclear fusion occurs when nuclei become so close that the electrostatic forces that ordinarily repels them are overcome. When this occurs, the nuclear forces take over and fuse the nuclei together, releasing energy and particles in the process. Fusion reactions usually occur in high temperature, high density environments. All the stars, including the Sun, are nuclear fusion reactors. To create what is essentially a small star on Earth, physicists need to achieve extremely high temperatures, pressures, and confinement times within their nuclear fusion reactors. This has proven to be an expensive and energy-intensive endeavor. No fusion reactor has produced more power output than input to date. If this could be accomplished, we could have limitless clean energy available on Earth. Atoms need to be raised to a very high temperature to be brought close enough to fuse. At extremely high temperatures, atoms are reduced to nuclei as their electrons are stripped off to form an ionized gas called plasma, the fourth state of matter. Without the electrons to provide electrostatic repulsive forces, the strong nuclear force allows the nuclei to be fused. Advantages of fusion power over fission power include reduced radioactivity during use, a reduction of radioactive waste, increased safety, and nearly limitless fuel. Some of the biggest issues surrounding nuclear fission power generation are solved with nuclear fusion power. Many different reactor designs have been implemented since research on fusion power began in the 1940s. There is no shortage of real-world examples of nuclear fusion reactors, although none of which have achieved a controlled, sustained reaction that uses less energy than it produces. The tokamak design is the world's most developed approach to fusion energy production. The design is shaped like a torus, or a donut, and employs a powerful magnetic field to confine plasma. Plasma is at such high temperatures that it cannot meet any material without melting and ionizing it. For this reason, magnetic fields are used to keep the plasma away from the wall's reactor chamber. This type of reactor is known as a magnetic confinement reactor and is the leading design in the race towards nuclear fusion power. The largest and most intriguing tokamak-style fusion reactor is the International Thermonuclear Experimental Reactor, or ITER. This gargantuan fuser weighs 23,000 tons and reaches 150 million degrees C. That's 10 times the temperature of the core of the Sun. ITER is the world's largest tokamak, although hundreds of smaller tokamaks have been developed over the years. This massive science experiment is meant to prove the feasibility of fusion power generation and is scheduled to be completed by 2025. Currently, researchers at a 1/10 volume mock-up of the $22 billion ITER tokamak are conducting experiments that will help predict how the plasma in ITER will behave. Their aim is to produce more power output than input with a sustained reaction. The Wendelstein 7X is a bizarre-shaped stellarator reactor built in Germany by the Max Planck Institute for Plasma Physics. This unique reactor is like a tokamak design that twists, making a very complex geometry. I was able to see an unused section of this reactor on a trip to the Princeton Plasma Physics Laboratory in Princeton, New Jersey. It is difficult to imagine that such a complex part was able to be manufactured, let alone the entire reactor. I found examples of fusion power generation in films like Iron Man and Interstellar. In the 2014 film Interstellar, the spaceship is fueled by compact tokamaks. In the Iron Man films, Tony Stark's suits are powered by a small fusion reactor. This small reactor is analogous to the world's smallest tokamak fuser at MIT's Plasma Science and Fusion Center, the Alcator CMOD tokamak. The idea behind this tiny MIT reactor is to have a compact device capable of immense power output, like Tony Stark's arc fusion reactor or the interstellar spaceship reactors. With the current challenges in the energy sector, the need for a clean, reliable, and renewable energy source is significant. Nuclear fission is the safest form of energy generation but produces toxic nuclear waste. Solar and wind energy are unreliable sources of energy requiring large areas of land. Another problem facing solar and wind energy is the fact that energy storage is difficult, and batteries are expensive and require conflict minerals to produce. Hydrocarbons, our primary source of energy, are dirty and limited. Fracking for natural gas is quickly polluting our water supplies and cannot continue without consequence. Nuclear fusion power generation has the potential to solve many of the world's energy generation problems with the promise of limitless clean energy.